Stop where you are right now and go watch my other video on Parabolas Part 4 before you watch this one. Then you can come back to this one. Okay, but let's go ahead and talk about this section. This is the last parabolas section. You have learned everything that you need to know about parabolas after you learn this lesson. So that's awesome. We're also going to talk about a few cool applications and things that you've probably noticed in your experience that have to do with parabolic shapes. Okay, so imagine that I have a graph and there's this straight line, the straight horizontal line, which is y equals 4. And let's suppose that I have a point down here, which is 3, 0. Now let's say that I want to draw a graph that is equidistant at all points from that point 3, 0 and the line y equals 4. Well, this shape would actually look like this. It would look like a parabola, okay, where that distance there is 2, that distance is 2. And if I were to figure out, okay, what's the distance between the line in the graph there and then back to that little point 3, 0, those two distances would be the same. Those two distances I've just drawn will be the same. All of the distances will be the same, right? Which means that this parabola that I've drawn is equidistant from the line, which I'm going to call the directrix, and from that point, which I'm going to call the focus, okay? So this is what we're going to learn about today, is how to figure out what the directrix is and what the focus is, and maybe if you have those two pieces of information, what would be the vertex. We're going to talk about an example of a real parabola. The parabola, there we go. Imagine that you have a candle sitting in front of a concave mirror, okay? And then this would be shaped like a parabola, so it would have a focus right there. Okay, so what happens is that this light beam that goes straight across from the tip is actually going to bounce back and go through the focus when it comes back through. And then something that goes through the focus on the way to the mirror is going to bounce back parallel like the first line that we drew. And what's going to happen is that these two lines intersect and actually make the image that we see in the mirror. And this image, as you can see from this picture, is going to be upside down, right? Look at yourself in a spoon and see how this works. See that your image in the spoon is actually going to be upside down. And this is how the focus of a parabola actually works. Okay, so we're going to have two kind of different pictures that we might see with parabolas. Now, this is the type of parabola that you have seen before, where I have an upward facing parabola. It also might be downward. But anyway, I have the focus, which is going to be scooped up by the parabola. So the parabola kind of scoops it up. I have this axis of symmetry that's going straight through the vertex, and it'll also go through the focus as well. And then I have the directrix down on the other side of the vertex. Okay, I'm going to call that distance between the vertex and the focus C. Okay, so this is a parabola in the form of y minus k is equal to a times x minus h squared. You have seen this before, and it also might be upside down, right? But always remember that the parabola scoops up the vertex. So, not the vertex, but the focus. Okay, so we might also have a horizontal parabola, which would look like this. In this case, I have an axis of symmetry that's going to be horizontal. My directrix will be vertical, and I'll be using the equation x minus h is equal to a times y minus k squared. Okay, which again, I have these c values, right? These are just the distances between the directrix and the vertex and the focus. And a is always going to be equal to 1 over 4c. And we'll figure out, we're going to kind of be ignoring the sign of a in order to figure out what c is, but we'll kind of go off our picture to figure out, what the signs should be really. So suppose that you're given a vertex 2, 4 and a directrix y is equal to 2. And let's suppose I want to figure out what the focus is, what that third thing is that is in relation to those two other things. So first I'm just going to draw this. Y is equal to 2 is a horizontal line going through 2. And then the point 2, 4 is above that. So I can see from this picture that this is going to be a regular sort of parabola where it's vertical. And since the vertex is 2 away from that directrix, then the focus needs to be 2 away from the vertex, right? And I know that the parabola is going to be scooping up the focus, so it needs to be on the other side of the vertex than the directrix is. And I get the point 2, 6 when I graph that. So let's go ahead and so here you can see that the parabola is scooping up my focus. Always remember that it scoops up your focus. Okay, so the focus in this second picture is going to be -3, -1, which is right there. And then I know the vertex is 1, -1. So the focus and the vertex are 4 apart, which means the vertex and the directrix also have to be 4 apart, which means the directrix is going to be the line x is equal to 5. And again, I draw my parabola such that the parabola is scooping up the vertex. Now let's suppose I have another example where the directrix is now x is equal to -2 and the focus is to 0. So I've drawn my directrix there, it's a vertical line, and my focus is the point 2, 0. I know my vertex needs to be right in the middle, which means it would be the point 0, 0. Okay, let's go ahead and find an equation for a parabola where the focus is 0, 0, and the directrix is x is equal to 4. Again, I really want to draw this to help me understand what's going on here. So first I would draw x is equal to 4, and right away I can tell that this is going to be a sideways parabola. The focus is 0, 0, so the vertex has to be right in the middle and it has to scoop up the focus. So then I know what this picture looks like. The distance between the focus and the vertex is going to be 2, and between the vertex and the directrix is also 2. Which means my c value is 2, and a is equal to 1 over 4c. So if I figure out what a is, it's 1 over 4 times 2, which is 1 over 8. Okay, but let's think about this. Is it opening left or right? If it's opening to the left, then my a is going to be negative. If it's opening to the right, then my a is going to be positive. Okay, so I'm going to use this standard equation for the parabola, that is the horizontal one, and I'm going to plug in my vertex so that I get that standard equation. Let's do another example where we are trying to get the standard form for the parabola. So now we're working with all these parabolas that are actually sideways, okay? And I'm going to post a separate video on just how to graph sideways parabolas, so you can look out for that. So let's suppose I want to find the vertex, the directrix, the focus, the axis of symmetry. I want to find the standard form for the parabola, and I want to graph it. Whew, that's a lot of things, okay? But really we're going to go kind of off the graph, really. So first thing I will do is I'm going to turn this into standard form. So I'm going to complete the square in y, so 2 alpha is equal to 6, alpha is equal to 3, alpha squared is equal to 9. So I'm going to add 9 to both sides to complete my square in y, so it's y plus 3 squared plus 8x minus 7 is equal to 9. I'm going to subtract that whole y plus 3 squared term, and I'm going to subtract 9 from both sides as well. I get 8x minus 16 is equal to negative y plus 3 squared. Then I'm going to divide everything by 8, and I get x minus 2 is equal to negative 1/8 times y plus 3 squared. So this is my standard form for the parabola that is going to be a sideways parabola because y is squared instead of x being squared. So the vertex here is the easiest to find. It's whatever makes the left side 0 and the right side 0, so that's 2, negative 3. So I'm going to draw this parabola as a first step. So I find the point 2, negative 3, and I plot my vertex there. And then I'm going to draw a quick sketch of my parabola here. Now notice that at first I'm like, oh, this is a downward facing parabola here. I have negative 1/8, therefore as I move in the positive x direction, I'm going to move in the negative y direction. And I'm also going to find my a value, which is equal to 1 over 4c, which in this case is 1 over 8, right? So therefore c is equal to 2. So then I might think, okay, the directrix is 2 away, the focus is 2 away, but wait a second, this is a sideways parabola. What am I doing? So I need to redraw this whole graph, and let's do it a little bit more slowly. So suppose that I have the point 2, negative 3, which is the same point as I originally had for my vertex. Nothing changes. Whatever is with the x gives us the x coordinate of our vertex. Whatever is with the y gives us the y coordinate. Okay, now I'm going to draw this the correct way, facing to the left, because it's a sideways parabola. Now I know c is equal to 2, which means I'm going to draw the directrix 2 units away from the vertex, and the focus 2 units away from the vertex. And then I figure out that that line's equation is x is equal to 4, and the focus is the point 0, negative 3. I also know that my axis of symmetry goes straight through the focus and the vertex, which means the axis of symmetry in this case is y is equal to negative 3. Let's go ahead and do another example where we have to complete the square, but this time it's going to be a parabola that you're more familiar with, where the x's are squared. So again, I need to complete the square, so I set 2 alpha is equal to negative 6, alpha is equal to negative 3, alpha squared is equal to 9. And I'm going to add 9 to both sides to complete my square in x. It's x minus 3 quantity squared plus 10y minus 1 is equal to 9. I'm going to subtract 9 from both sides and subtract that whole x business to the other side, and I get 10y minus 10 is equal to negative x minus 3 squared. I'm going to divide everything by positive 10. And I get y minus 1 is equal to negative 1/10 times x minus 3 squared. Let's go ahead and figure out what the vertex is. It's just whatever makes that whole right side 0 and the whole left side 0, so it's 3, 1, right? So I'm going to plot that point 3, 1 is my vertex. Okay, now I know that this is an upside down parabola, and it's a regular vertical one because x is squared and not y. So I'm going to just quickly sketch that. It doesn't have to be accurate. And then I'm going to figure out what c is. 1 over 4c is equal to 1/10, which means 4c is equal to 10 when I cross multiply. Therefore, c is equal to 10 over 4, or 5 halves. Okay, so I'm going to go 5 halves away from the vertex to plot my focus, which is going to be the point 3, -3 over 2, and then 5 halves away up from the vertex to plot my directrix. So that one is going to be the line y is equal to 7 halves. So that's my directrix, and then last is the axis of symmetry, which is the line x is equal to 3. I have solved for everything they asked for. So I'm finished with that problem. Just make sure that you've watched both videos on this topic. I would have watched the other one first if I were you, but it's also fine if you watched this one first. Anyway, good luck on your homework, and have a great day.